Looking at mechanisms today, mechanisms are defined as process by which a reaction occurs. Now, a reaction with a single mechanism reaction is called an elementary reaction. We have three types of those. If the reaction is either has one reactant or a first order, we call that a unimolecular function. If it's got two reactants or second order, we say that the reaction is bimolecular. Or if it's got three or third order, or even more than that, we say that it's a termolecular function from there. All right, now, we can also have a multi-step mechanism reaction. We have multiple steps. So how do we know when the reaction takes place? We want to identify what's called the rate determining step. What is a rate determining step? Rate determining step is a step that identifies the rate of reaction due being the slowest step, the one that generates the slowest speed. In this particular example, and I'll show you an example of this in class, the second step, the formation of iodine, is our rate determining step. It's our slowest step. All right, now, we do have four factors that affect rate of reaction. The first one is temperature. As we increase temperature, the rate of reaction increases. The second is particle size. As particles get smaller, the reaction increases because there's more surface area for the reaction to take place on. Third is concentration. As we increase concentration, reaction rate increases. And the last is something called a catalyst. What exactly is a catalyst? Catalyst is defined as a substance that increases the rate of reaction without being consumed. So how does it happen? Let's say I have a reaction where I have energy versus time. We have our reactants and our products. And our reactants are usually a slightly higher energy state than our products due to entropy. Remember, we talked about a measure of a disorder in a system. In order for the reaction to overcome, we have to usually overcome a specific amount of energy. We refer to that as the E sub A, or the energy of activation, defined as the energy needed for a reaction to proceed. Okay, now how do we, what does a catalyst do is it lowers that energy activation, makes it smaller. Now there are two different types of catalysts. It can either be heterogeneous catalyst, so it's this opposite state from my catalyst. So if my reaction's a liquid, my catalyst will be a solid, or homogeneous catalyst where they're all in the same phase. All right, lastly then, there's two ways we can do complex catalyst. First is a catalytic complex, which is a substance that reacts to form a compound that will bring the two compounds together more rapidly. I've got a video here. I'll show you in class. The second is a substrate. Substrate is defined as it provides a substance with reaction provides a substance on which a reaction take place. Again, this is a video. We'll show this in class. An example of a substrate will be enzyme. We'll talk about this in class as well. Hopefully this wasn't too bad. Take care. Be good. Bye.